My name is Stephen Baumgart from University of California at Santa Barbara. Our project is to create a predictive system using EEG recordings to predict truly random events in the future. We do this by putting participants in a dark, soundproof room with white noise. And completely randomly, a stimulus is chosen out of three choices, either a light flash, an auditory tone, or nothing, chosen with equal probability. So there's no way for the participants to guess what is upcoming. This entire time, they're wearing an EEG cap, recording their brain activity. We use a quantum random number generator to choose which of these selections. So there was no way for them to normally predict what is about to happen. So any effect would be precognition. We recorded this data from all these participants and analyzed the data in three different methods. The first method is event-related potentials, or ERPs, where we take the average of the voltage recorded by the EEG system. In this analysis, we found evoked potentials representing the brain's processing of the visual and auditory input. And we could see how the processing developed through the brain. Unfortunately, we did not find any precognitive effect using this method. The hypothesis that the future effect would be reflected into the past was not verified by this method. The second method was alpha waves. When the participants sit in this dark room with white noise, they have a lot of alpha waves at between 8 and 12 hertz in frequency. We see these oscillations in our data, and when the stimulus turns on, the oscillations disappear. We saw a large effect after the stimuli started. We also looked for this before the stimulus in the precognitive region, but we did not find an effect this way either. One analysis, the final analysis, was more successful, which is machine learning. This is called an Euclidean distance analysis. And in this case, we look at the current event and we compare it to all previous events. The previous events, we know what the stimulus was, whether it was light, sound, or nothing. And we can create templates from these various types. We compare the current event to the past events and see what it matches most closely. For example, if we were looking at event number 50, we could compare to events 1 to 49 and classify 1 to 49 by the type light, sound, or nothing, and seeing which event 50, was most similar to, which average event 50 is most similar to. This was more successful. It was extremely successful in allowing us to identify the event type post-stimulus, but also pre-stimulus, we also had a weak effect. So this is the most promising method using the machine learning technique. So though the effects were weak, our lab learned a lot from this experiment, and we hope to apply our methodology for future experiments. And I'd like to thank the BIAL Foundation for funding this project. If I had one word to describe the BIAL Foundation, it would be innovative,